So section 14.4, center of mass. Let's start with the first question. Find the mass of Luminia described by the inequalities. Here's the inequalities: x between 0 and 8 and y between 0 and 8. And the density function is p of xy is equal xy. So here's all the information. That means x between 0 and 8. So x is 0 here and 8 here. Y between 0 and 8. So here's y0 and y8. So here is our region. So m equal the integral between 0 and 8, 0, 8, xy, dx, dy. If you do dx, dy, dx is going to be the same result. So I'm going to do the integral for dx, dy. That means we're going to do the integral for the x first. So for the x, the y is constant. So it's going to be x squared over 2 from 0 to 8. Plug in the 8. So it's going to be 8 squared over 2 minus 8. And here is the y, then dy, which is going to be 64 over 2. That means going to be 32. I'm going to take the 32 out as a constant. And the left is going to be integral from 0 to 8 y dy. So it's going to be y squared over 2 from 0 to 8. And then it's going to be 8 squared over 2 minus 0. Then it's going to be 32 times 32. And the result is going to be 1024. So we're just going to plug in 1024. That's it for this example. Here we go. We're going to try it. Let's go to example 2. Exactly the same thing. Our density function is xy, and x between 0 and 2, but y between 0 and 4 minus x squared. So let's check. The second one is going to be x between 0 and 2, and y between 0 and 4 minus x squared. 4 minus x squared. So 4y is going to be equal negative x squared minus 4. It's a parabola, reflect over x-axis and shifted up 4 units. Parabola, reflect over x-axis and shifted up 4 units. And x is between 0 and 2. Between 0 and 2, that means here is our region. That's what we're going to study. So now it's going to be the integral. Here is a function. Inside is going to be dy. That's why the outside from 0 to 2, from 0 to y equal 4 minus x squared, xy, dy, dx. Then we're going to do the integral here. That means it's going to be from 0 to 2 with respect to the y squared over 2, from 0 to 4 minus x squared dx. Then a plug in. So it's going to be x 4 minus x squared over 2 minus 0 over 2. This is cancelled, and here's dx. So here's x. Now we're going to FOIL this one. So it's going to be 16 minus 8x squared plus x to the power 4 over 2 dx. Then take the 2 out. You want to keep it. What I did, I distribute the x 16x squared. Then I took the 1 over 2 out. And I'm going to do the integral for here, for each part, each term. So it's going to be 16x squared over 2, 8x to the power 4 over 4, and x to the 6 over 6. Simplify. So here's half 8x squared minus 2x to the power 4 plus x to the power 6 over 6. Now we're going to plug in 2 minus the 0. Plug in the 2 is going to be 8 times 4, 32. 2 times 16, 32. And 2 to the power 6 is going to be 64 over 6. So it's going to be half, because these cancel. Half times 64 over 6, 64 over 12, which is 16 over 3. So that's our solution, 16 over 3. So we're going to plug in here, 16 divided by 3. That's it for this example. We're gonna try it. Let's go to example 3. Here is example 3. So what I did with example 3, because you're gonna get exactly the same thing. So I solved A and B and I left C for you. You're gonna do exactly the same steps when we did on A and B. So find the mass and center of mass of the lumina corresponding to the region. So for A, our region P equal K, the density, and we need to find M. That's why always I recommended to watch the slides before you're doing these examples, so you can know when I'm doing these steps. So A is P equal K. So the first thing, we need to find X var and Y var, which is My divided by M sub X divided by M. This is the Y var. So first thing, I'm going to find the M. M is going to be, for this region, they give you the region, R is the square with the vertex 0, 0. So here is the point 0, 0. And with the point 0, A and A0 and AA. So here is our region. That means it's going to be integral with respect to the X from 0 to A, for the Y from 0 to A, K, here's our region, the density, dy dx. Let's find the integral from 0 to A with respect to the Y is going to be ky from 0 to A dx. Then from 0 to A, plug in the A, so it's going to be Ka now with respect to the dx. Find the integral with respect to the dx, so it's going to be Kax from 0 to A. So it's going to be Ka squared. So this is the M. Now X var and Y var. First of all, we need to find the My. My is going to be the integral from 0 to A, from 0 to A, Kx, K. X with the K. Dy dx. Then the first thing, I'm going to find the integral with respect to the Y. So it's going to be Kx, xk, y from 0 to A with respect to the dx. Plug in the A, so it's going to be xk with A dx. Then go ahead, find the integral with respect to the x, so it's going to be x squared over 2 and ka. Plug in the A, so it's going to be a squared over 2, because this one is 0. A squared times A is going to be a cubed k over 2. Now this is the M sub y. X var is going to be M sub y divided by M sub y divided by M, and simplify it. How are you going to simplify it? You're going to say a cubed k over 2 times, this is over 1, so it's going to be 1 over ka squared. Cancel the k with the k, a squared cancel a cubed with a squared, so the left is going to be a over 2. That means we have a over 2. Now we're going to find the y var, which is M sub x divided by M. So we're gonna, from 0 to A, now yk dy dx. We're gonna add to our density function, we're gonna add y, because we need to find sub x, so we're gonna add y here. So yk dy dx. So now we're gonna find the integral with respect to the y, so it's gonna be y squared over 2 from 0 to A. Then plug in the A, is going to be a squared over 2, and here's the k. Find the integral with respect to the x, so it's going to be a squared over 2 kx, and also from 0 to A. Then plug in the A, so it's going to be a squared over 2k, and here's a minus 0. Here's the A times, so it's going to be a cubed k over 2. That means y var is going to be M sub x over M, which is a cubed k over 2, which is the M sub x divided by M. So here is M sub x divided by M, which is this one. So the result is going to be a over 2. That means for the first one, we're going to plug in m, which is k a squared. So k x squared, x squared. And x var is going to be, here's x var, a over 2, a divided by 2, and we're going to put comma. Y var is going to be a over 2. So we're done from the first one. Let's keep going to find B. I'm going to solve this one also, but C is going to be for you because you're going to get exactly the same example. Now, our density is P equal KY. We're going to do exactly the same steps. So this is from the previous part. Now, our density is P equal KY. So we need to find the M from 0 to A, from 0 to A, ky dy dx. Again, we're going to find the integral with respect to the y first. So from 0 to A, y squared over 2, and here is the constant k. From 0 to A, plug in the A, so it's going to be a squared over 2. Find the integral with respect to the x, so it's going to be k a squared over 2x, because the whole thing here is a constant. From 0 to A, that means going to be a, so k a cubed over 2. This is the m. Find m sub y, which is the integral. We're going to add x to the density. We're going to add x. So it's going to be x ky dy dx. Then find the integral with respect to the y. So it's going to be y squared over 2. This is a constant from 0 to A. Plug in the a, so it's going to be a squared over 2. Now find the integral with respect to everything here is a constant. Find the integral with respect to the x. So it's going to be x squared over 2, ka squared over 2 from 0 to A. Plug in a here. A squared times a squared, a to the power 4. 2 times 2 is going to be 4, and here is the k. So here is m sub y. X var is going to be m sub y over m, which is equal a 4k, a to the power 4k over 4 divided by m. Then simplify this one, cancel k with the k. 4 divided by 2 is going to be 2. A4 minus 3 is going to be 1. So here is our x var. Now m sub x is going to be the integral. We're going to add y here. So y ky dy dx. Y times y is going to be y squared. Find the integral with respect to the y. K is a constant, so it's going to be y cubed over 3 from 0 to A dx. Then it's going to be, find the integral with respect to the x. Oh, we're going to plug in the a, so it's going to be a cubed over 3 dx. Then it's going to be ka cubed x, because we're going to find the integral with respect to the x. Divide by 3 from 0 to A. Then plug in the a, so it's going to be a to the power 4 divided by 3. And here's the k. That means y var is going to be m sub x divided by m, which is equal to k a to the power 4 divided by 3. This one divided by m. 3 divided by 2 is going to be 2 over 3, because you're going to flip the reciprocal, take the reciprocal for the second one. K with the k cancel, and the left is going to be a over. So it's going to be 2a over 3. You can do it like this. K a to the power 4 divided by 3 times 2 over k a cubed. Cancel k with the k. 3 goes with the 4 goes with the 3. The left from the top is 2a over 3. So that's for the second part. So we're gonna plug in here ka cubed over 2. This is our m. And x var is going to be a over 2 So fraction 8/2, and our y var is going to be 2a/3. 2a/3. Yes, let's check that. I didn't notice that I plug in with the first one, x instead of a. This one is supposed to be a. Here we go, we got it right. So for the part C, you're gonna do exactly the same steps what we did with the part A and B for this example. So for example 4, we need to find the mass and the lemma for and the center of the mass of the lemma bounded by the graphs. So y equals square root of x, y equals 0, x equals 1, and the density is p equal ky. So first of all, let's try to graph it. Y equals square root of x. So here is the square root of x function. Y equals 0. That means it's bounded by y equals 0 to the square root of x, and x, then we have x equal 1. So here's x equal 1. That means our region is going to be here. Density is going to be, so now I have a curve here. So I'm going to put this one inside as a dy, and the outside rule bound from 0 to 1. So from 0 to 1, and the y from 0 to y equal square root of x, ky dy dx. Let's start finding the integral with respect to the y. So it's going to be y squared over 2 from 0 to square root of x. Plug in square root of x here, and this one is going to be x divided by 2. Now find the integral with respect to the x. So it's going to be x squared over 2. I took k over 2 out, so I'm not going to confuse myself. And here's the x dx. K over 2 as a constant is going to be x squared over 2 from 1 to 0. Plug in 1 is going to be half over 1 over 2, which is half, minus 0. That means it's going to be k over 4. So our m is going to be k over 4. M sub y, which is from m sub y is going to be from 0 to 1, from 0 to square root of x. We're going to add x here, x ky dy dx. So it's going to be from 0 to 1, x. We need to find the integral with respect to the y. So it's going to be y squared over 2 from 0 to the square root of x dx. Plug in the square root of x here. So it's going to be x over 2. This one is going to be x over 2. And x times x is going to be x squared. So this one is going to be x over 2. And x times x is going to be x squared over 2. Kx squared over 2 dx. Find the integral for this one, k over 2 as a constant. So it's going to be x cubed over 3 from 1 to 0. Plug in the 1, so it's going to be 1 over 3. So it's going to be k over 6. That means x var is going to be my over m, k over 6 over k over 2. Cancel the k, so it's going to be 2 over 3. And this is how it's happened, k over 6 times 4 over k. Cancel the k, simplify this one is going to be 2 over 3. So we're done from the first part of the x var. We need just find the y var. So I'm gonna plug in here the m, which is k over 4. So I'm not gonna forget k over 4. And the first part here is 2 over 3. 2 over 3. We need to find now the y var. So to find the y var, we need to find m sub x. That's mean integral from 0 to 1, from 0 to square root of x, y. We're going to add y to our density function, ky. Y times y squared. This is a constant. We need to find the integral with respect to the y. So it's going to be y cubed over 3 from 0 to square root of x. Plug in square root of x is going to be square root of x cubed, which is equal to 3 over 2. K over 3 is a constant. Find the integral for x 3 over 2. You're going to add 1 here. So it's going to be 5 over 2 divided by 5 over 2. K over 3, x 5 over 2. Flip this one is going to 2 over 5. Now 2k over 15, x 5 over 2 from 0 to 1. Plug in the 1. So the left is going to be 2k because this is 0, cancel everything. So it's going to be 2k over 15. That means y var is going to be m sub x over n, 2k over 15 divided by k over 4, 2k over 15 divided by 4 over k, cancel the k with the k, is going to be 8 over 15. That means our y bar is going to be 8 over 15. So we're going to plug in here 8 over 15. That's it for this example. You got it right. Now let's move to example 5. Find the mass and the center of mass of the lemma bounded by the graph of the equations for the given density, which is y equals 6 over x, y equals 0, x1 and x5. And we have p equal kx squared. So we're going to do exactly the same steps. But the first thing, we need to find how to graph it. So we have, this is our p, x between 1 and 5. So between 1 and 5. x1 and x equal 5. So here's x5 and here's x1. How to graph the y? Plug in when x is 1, y is going to be 6. When x is 1 here, y is going to be 6. When x is 5, y is going to be 1 point, because 6 over 5, 1.2. So here is the 1. 1.2 is going to be here. Between 1 and 2, less than half, 1 and 1/2. So it's going to be here. That means here is our curve, y equals 6 over x. So that's our region between this curve and y equals 0, x equals 1, and x equals 5. So we're going to say the integral from 1 to 5, the x, and the y inside, because it's from 0 to the curve, from 0 to y equals 6 over x. Kx squared dy dx. Find the integral with respect to the y. So kx squared is a constant. Here is the y from 0 to 6 over x. Plug in 6 over x here. Cancel x with the x. So it's going to be 6kx dx. Find the integral with respect to the x. It's going to be x squared over 2. 6k is a constant. I'll plug in 5. So it's going to be 25. 5 squared minus 1. And 6 divided by 2 is going to be 3k. 5 squared minus 1 is going to be 25 minus 1. That's mean 3k times 24. So it's going to be 72k. So this is the m. Now we need to find m sub y. So we're going to plug in here 72. 72k. Now m sub y is going to be integral from 1 to 5. We're going to add x here, y. Sorry, x, kx squared, because we need to find m sub y. Dy dx. It's going to be from 1 to 5. X times x cubed, dy dx. We need to find the integral with respect to the y. So it's going to be x cubed y. The whole thing is a constant. Plug in 6 over x. So 6 over x, cancel x with the x. So it's going to be integral from 1 to 5, 6k x squared dx. Now find the integral with respect to the x. The whole thing here, 6k is a constant, so it's going to be x cubed over 3 from 1 to 5. That means cancel 6 with the 3, 2k, plug in the 5. So 5 cubed minus 1 cubed. 2k, 125 minus 1. So 2k times 124, so it's going to be 248k. So this is m sub y. Now to find the x var, we're going to divide m sub y, divide by m. So 248k divided by 72k. That means x bar is going to be m sub y divided by m, is going to be 248 divided by 72. Cancel the k with the k. Divide by 8 is going to be 31. Divide by 8 is going to be 9. That means the first part here, the x bar is going to be 31 divided by 9. And we have to put comma. Let's check the y bar. M sub x is going to be from 1 to 5, from 0 to 6 over x, y, k x squared. Find the integral with the y, so it's going to be y squared, because kx squared is going to be a constant, y squared over 2, plug in 6 over x. Be careful here. Take kx squared over 2 out, so you're not going to confuse yourself when you plug in 6 over x. So plug in 6 over x in the y, so it's going to be 36 over x squared, and this is 2 over 1 is going to be 1 over 2. That means 36 over x squared times 1 over 2. 36 with 2, x squared with x squared, the left is going to be 18k dx. Now find the integral for 18k with respect to the x. 18k is a constant, x from 1 to 5. That means it's going to be 5 minus 1, and it's going to be 4. So 18 times 4 is going to be 72. That means y var is going to be m sub x over m. 72k divided by 72k is going to be 1. So comma 1. That's it for this example. There we go. We got it right. This is the whole thing for section 14.4.